Hello everyone, my name is Krishan. So in this series, we're gonna learn more about design patterns, especially in TypeScript. Why design patterns are useful in the first place? Because design patterns are typical solutions to common problems in software designs. Each pattern is like a blueprint that you can customize to solve a particular design problem in your code. And if you ask me, what are the benefits of their patterns? So the patterns are a toolkit of solution to common problems in a software design. So suppose if you have a common language that helps your team, so everybody can use that. So design pattern is something like everybody can use that. It's across the team, across the business units, and across the organizations. So that's why it's very useful. Yeah, so now we're gonna learn about what are the different design patterns. So there are like 3 design patterns as of now. There are more as well, but 3 more common design patterns are creational, structural patterns, and behavioral patterns. So today we're gonna talk about creational design patterns. And what's basically the creational design patterns? So creational design patterns basically are the design patterns which provides various object creation mechanism, like which increase flexibility and reuse of existing code. So creational design patterns. And in this video, I will talk about factory method. So inside creational design patterns, we have something called factory method. And why factory method is being used, why we use that, what is purpose, we're going to talk everything about that. So in factory method, we provide an interface for creating objects in a superclass, but that also allows your subclasses to alter the type of objects that will be created. Okay. For an example, let's take a problem statement first. Why we require factory method. What's the problem statement? Suppose. So you have a really nice app for a firm. That's a logistic firm, and that has a mode of transportation, road. You have your coupled class, truck class. Now your app has become much more famous now, suppose, and you are in demand, and everybody's like, oh, I want to use your app in terms of our logistics. So, and much more demand are coming from the sea transportation area. So what you're gonna do? You're gonna make another class, ship class now, and create everything again. What if another time comes through the flight class? See, suppose that would be through the flight transportation. So you will make another class. So that seems like now you are adding, making changes to the entire code base, like for ship, for flight. Moreover, it'll later you decide to add another type of transportation. Suppose another type of transportation comes at, which is some sort of hybrid, or you probably need to change something. So how are you going to do that? That would be so much messy in the code base. You have to add so much of, duplication of the code because you already have a truck class, you have a ship class, and you have a flight class. So how are you going to do that? So in that, we have a solution, which is factory method. We will use factory method. It will generate for us under this method, we will have with the use of new operator, using the new operator, we will call the special factory method, and we will create the interfaces also. Okay. So now let's do that, like how we're going to use it. Like, let's try to have some code, pseudocode sort of logic out over here. Okay. So suppose you have an interface now. You're going to create an interface. Let's take a step-by-step explanation. Step by step, step by step. First, let's define interface for a product. So that could be ship transportation, flight transportation, or road transportation. Our interface will be same. So that's in TypeScript. So anybody who's from Python or Java, they can just look at the syntax as almost the same. Or you can just Google it. So like, let's take interface shape, and you have to draw something, and I'm giving it void because that's not returning as of now, and I don't want to have any error. Okay, so this interface basically defines the common functionality of shape. So you can draw a square circle in this example, and that must be implemented because it's a shape interface, and the function which we are calling is draw. So it could be square, it could be circle. So, it will implement the functionality which is draw. So it could draw a circle, it could draw a square. Second step in our factory method, we have to create concrete product classes. So we have to create concrete product classes. Okay. So creating a concrete product classes, what you have to do. So now I'm going to create one concrete product class. Suppose I have a class circle. I have taken an example of circle. Circle implements. So my circle implements the shape, which is my interface. And I'm using the function draw over here, which is void. And under that, I'm using a console.log, drawing a circle. Let me close it. The similar manner, you can do that for the square. Like, you can use it for the square and implement that in the same way. So now you have one for you implemented the shape interface and the draw function for circle, and now for square. These classes represents the specific type of objects that can be created by the factory. So now your factory has created basically one of, class represents circle, the another represents square. So it represents the specific type of objects that can be created by a factory. Now I'm going to go to the factory class. The third step, define the factory class. So my class shape factory, it will create a shape. Let's take, it's creating shape. And it's creating shape, and it has a shape type. Let's say it has a shape type, camel case, string, it's a shape type of string, close. That's calling shape. And now I have a switch over here. I can use a switch, shape type. So case, circle, shape type, circle. Okay, let me rub it. So it will return new circle. But if the case type is square, it will return a new square class. And then we can have a default as well, so that we are not in an infinite loop. Throw new error. Let's define invalid shape type. So you saw that like the shape factory basically class. So the shape factory class acts as the factory, and it's responsible for creating and returning the appropriate concrete product class based on the provided shape type. Now, how our client gonna use it? So let's take a recap what we did. Okay. Um, so that was one example, problem statement, which I told you. There's another problem statement similar to that, in like you have different shapes, and how you're gonna do that. So for the shapes, you made an interface which is shape, and after making the interface, you made a function in that draw, and you made two concrete classes for your product classes. One is circle, another is square. And then you made a factory class, which is calling both of them on the basis of switch. Like if it's case circle, it's returning a new circle. If it's case square, then it's returning a new square. So you see the new operator. With the help of the new operator, we are creating the objects of the concrete class in the factory class. And in that way, if suppose a rectangle comes in someday, so I will just make a class rectangle implement shape, and that will implement the draw. Uh, and then we can have drawing a rectangle, and then I can use that inside my factory class. I don't have to, um, you know, go into the code base and add everything again, define new classes. It's just a simple new class and then adding that again. Now the final step, how a client gonna use it. So how the client code usage gonna work in that. So suppose you have a constant shape factory, which is we have, and with a new operator, we have shape factory. It's gonna call shape factory. So it will create an instance of that. Another thing is constant circle equals to shape factory dot create shape, and then we're gonna pass circle in that. Oops, but and then we can call circle dot draw. So the client code interacts solely with the factory, and it's requesting the factory. You can see like it has shape factory, which is calling the new shape factory, which is a factory class, and it's requesting the factory the desired object type it wants, and receiving the created object type which it wants. So this approach promotes loose coupling and simplifies extensibility, as new concrete product class can be added without modifying the client code. So we don't have to much modify the client code, and without, if suppose the client wants square, simply like it can call constant square equals to shape factory dot create shape square, and our factory class will give it the square object. So what are the benefits of using, a factory method pattern? So it decouples your object creation, first of all. So the client code doesn't need to know the specific concrete product classes. So over here, my client code doesn't know that I have a concrete class of circle, I have a concrete class of square, and in future, if I have a concrete class of rectangle, it only communicate with my factory class. Behind the scenes, I have very decoupled solution of factory method, which is providing all that things to me. It also promotes loose coupling. Also, it sort of like an encapsulation of object creation logic, like how my objects are creating over here. It's being very much encapsulation that. One of the most interesting feature if factory method is it's had facilitates the extensibility. So let me write down all the benefits, because it has an immense amount of benefits. Decouple. So decoupling is very much important, and it's decoupling of object creation. It also promotes loose coupling. That's something sort of like decoupling and loose coupling goes together. So I'm not, but encapsulation, like how it encapsulates object creation. That's one of the things which I like most about factory method. And then the third thing, how it facilitates the extensibility of your code. So that is another thing which I liked about it. Extensibility. So decoupling of object creation, encapsulation of objects, and facilitates extensibility. If you have to add another concrete class and then just make an object of that in your factory class, and then your client code can use it. So your client code is pretty much unaware what's happening. It's encapsulating object creation logic and giving you the flexibility to not mess up the code base on a regular basis. It's just very clean, and when you have to extend something, very clean extendability it provides. That's all for today. We're gonna learn more about the abstract factory method in the next session. Thank you.